Pedro Cruz, an assistant professor in the Art and Design Department at the Northeastern University, where he teaches information design and data visualization. He co-directs the Co-Lab for Data Impact and is also a core member of the Center for Design. His talk is going to be Visualization, It's Natural.
Hello, hi everyone. As I was introduced already, my name is Pedro Cruz. I'm an assistant professor at Northeastern University, where I teach information design and data visualization. And today I wanted to tell you a little bit about my own approach to data visualization, which is about nature-inspired metaphors, natural systems, and how I try to embed those metaphors into my visualizations. The first example that I wanted to tell you about is the 3 rings visualization of immigration that I think some of you are already familiar with, but I'm sure that not all of you heard me speak about it, so I wanna mention it a little bit to you. So this is a cross-section of basswood that's named for Tilia americana. That's an endemic species of North America. And I wanted to use this idea of a tree growing in order to show immigration coming to the United States. And this came in a time where we were feeling that anti-immigration speech and discourse in media, and I wanted kind of do something to counter-interact that. That basswood piece is actually very important for me because it's where I started prototyping my algorithm on pen, on wood, and observing how the 3 rings vary in thickness and how they behave so that I could make something that really looks like a series of 3 rings. This is one of the final artifacts, which is a visualization that shows all waves of immigration to the United States since 1830, and they come from several directions. From Canada, Oceania, Asia, Europe, the Middle East, Africa, and Latin America. So I made this physics engine that basically tries to mimic how cells grow on a tree. So I make those cells grow and then push the others outwards. Okay? Nonetheless, this doesn't always work. So the problem here is that, such as we have in trees, the new cells grow just below the bark, so they have this constant pressure being exerted on the cells. And that way, I had to make those cells being born just in the outer layers of my 3 rings, so that I have that compression force as well. At the same time, I'm also trying to mimic environmental conditions of trees so that sometimes they grow more in one direction than the other. If you look at the thickness of 3 rings, sometimes they are thicker in one direction than the other, and that's because sometimes there is more sun on that side, sometimes there is more humidity on that other side. So this is why they are annual 3 rings. My 3 rings, they aren't annual, they are decennial, so they are at every 10 years. And this is because I'm using census data, so that's why we have to make that extra jump in there. This is a visualization that shows every country that I have in my data set. Because it's a full visualization, I aggregated them, I colored them by region, right? But we have every country that contributed to immigration. And for each 100 immigrants, or 150 for this one, I plant a new cell, which is a very small dash, right? And those cells accumulate, and they start creating these layers. And we can look at several stories here. So we can see that most of the immigration started coming, at least globally in the US, from Europe. Then we can see in the 1950s, if you see those very thin rings over there, that's after the Second World War, where there wasn't a lot of immigration coming to the United States. We have in the 40s, immigration from Asia increasing because there was a lift on an immigration ban that the United States had for a long time, and more recently, a big wave of immigration from Latin America. This can also be visualized as a cartogram, right? So we can have a tree for each state, right? So that we can talk about the US as if it was a forest made of trees, right? And we can have, and we can see that each state has its own identity in the sense of the makeover that made it grow. So we can see that Florida and Texas are very skewed towards the south, so there is a lot of immigration coming from Latin America. Please remember that this isn't a deterministic visualization, meaning that there is a very high probability of a cell that is coming from North America to grow at the bottom, but it's only a very high probability, so you can find a yellow cell anywhere, right? And this is basically what enabled me to achieve this natural looking effect, because I'm using a Gaussian function, which is in nature everywhere, so there is a high probability of things appearing in certain directions, right? We have immigration from Asia, very prominent in California. And actually, the first take on this project also included what I call the natural borns. So people that were born in the United States as well, those were colored as being gray cells, because I wanted to show how much immigration contributed to the growth of the country. This is a printout of the Massachusetts state only. And we can see several waves of immigration from Canada, Europe, Latin America, and some from Asia more recently. But we basically have here a registry. You know, every dash here is 100 people, and so you can see everyone that theoretically ever passed through that country. So either was born there or arrived from outside. So it's like a mark in history, right? And this is why it's kind of poetic in the sense that you can count the 3 rings, go back in time, right? It's also poetic in a more morbid way in the sense that just like in trees, those are dead cells. And indeed, most of these folks are long gone. So we made a huge printout of all of these 50 states, and we had an exhibition called Naturalizing Immigration. We had a big wall that was laid out from west to east, and we laid out all of our prints just like geographically they are, right? And they have different sizes, so the bigger states are bigger. And if you have it in physical, right, you can really appreciate all the details that you can see in the visualizations themselves. We also had other instantiations of this project. At the right, we can see a tree ring that we made for the state of Rio de Janeiro. So this is in an exhibition in Rio. So the state of Rio de Janeiro in Brazil. And this is showing internal immigration from other states to Rio, right? So whether they came from south, from the west, from the north, the northeast, and so on. And here we have another simulation of immigration only to the state of New York. This was on show at the Museum of New York City. And this is just to show you that it's a project that can be applied to other contexts, doesn't have to be strictly to the United States. Still on this wave of talking about diversity, I recently finished a project called Diversity Traces, where I wanted to look at diversity, not from a geographical perspective, but within the household, within the families. So I thought to myself that that would be a very interesting problem in terms of visualization. How do I visualize in this case? I tackled it from looking at multiracial couples, so couples that are of different races in the US, and how much they have risen recently and how rare they were in the past. So it was like, it's more like a celebration of these new couples that we see more in society, at least in the United States. We have different sample sizes. It's very interesting because we have 100% sample sizes from the 1860s to the 1960s. So in the visualization, you'll be able to see every multiracial couple that was ever registered in the census, ever, right? And this was even in times when such marriages were forbidden. All right. And for that, I use this particular encoding I have to dashes with a height that is proportional to the age of each participant of the couple, of each spouse, apologies. We have a yellow dot that designates the head of household, and this is interesting to see because as we go through our simulation, to our visualization, we'll be able to observe that we have more women being head of households nowadays, and you can find those in the 1860s, for example. We have color. Color is going to be corresponding to race according to the categories in the census, which are native, multiple races, Asian, black, and white. I also have some connecting tissue between these two chromosomes, let's put it like that, figuratively, right? Which are their children, right? So you can see those traces that connect the lines, the main lines. And those are the number of children, which are positioned according with their age. So you can actually see when they were born. So if you have children that appear more at the bottom, they were born recently. And the ones that are older at the top, they were born more when the couple was starting, right? You can also look at age differences here. And we also have an L to designate Latinos. This is another, I'm basically following what information we have in the census, and that's an extra category, which isn't a racial category in itself. It's an ethnic category, and a Latino can consider themselves of being of multiple races. Now I want to show you. So this works as a interactive website. We can see here that 10 almost 11% of couples in the United States are multiracial nowadays. And I have all the groups here, right? Starting from the rarest to the more common, right? Being the rarest, Asian and Native. And this is a typical zoom on details visualization, as you can browse through all the couples that actually made the data set. And again, this is a 1% data. And they dance a little bit, all right, to convey a little bit more that these are indeed people. And I thought this was very important to try to preserve, try not to aggregate people into numbers, right? Just that, right? Basically trying to, if there is a couple, let's show a couple, right? Right? But let's show a couple in all its diversity. So they have different heights, they have different colors, they have different genders in this case, they have different races, and they have different ages. So the small numbers that you can see from there, but you can see online, you can also look at their ages. For example, they are sorted like this. So I start with the youngest couples with no children, then I have the younger couples with one child, 2 children, and so on. Right? So this one that I have here, it's a 42-year-old woman and a 38-year-old man, Asian and Native, 4 children. Both see themselves as Latinos as well. And we can also look at the color of their children, right? So their children. One of them considers themselves as being Asian, and the other two consider themselves as being multiracial. Right? So we can look at all of this diversity here. Oh. We can also look at same-sex couples. They are highlighted there, because else it would be very hard to identify them. And we can basically explore this. If we go here, we have 8 children, a couple with 8 children, multiple races and white, and the children themselves also classify themselves differently, right? So there is that sort of variation as well. We can just make a quick jump to the 1860s, and these are all the multiracial couples that were registered in the census in the 1860s. And this isn't representative at all of what was happening, right? This is only the census, right? And it's very natural that people had hesitations into appearing in these registrations, right? And also there was a census official in the 1860s, so it's not like you were giving your answers, they were interpreting what you were, right? So this data is indeed problematic, but it is what we have. On a more recent project that I'm currently working on, and trying to follow this theme of metaphors, I'm finally trying to working a little bit with temperature data and working a little bit with climate change. So as you can see, my work usually tackles social issues, and for the first time I'm going with trying to how to depict the growing rise of temperatures in ways that we haven't seen, and there is a lot that has been done already in this field, so it's a kind of complicated challenge. So this is an ongoing project. It's not finished at all, but I wanted to bring here our initial explorations of metaphors, and we're facing this project as a series of visual explorations of a series of metaphors about the rising climate change. And we started with a data set of 100,000 climate stations that show temperatures throughout the world. You can see their distribution. We have data since the 1850s until recently. And you can see negative temperatures in cyan and positive temperatures in red. Right? If we map things out to the United States only, for example, and we map the color with a gradient to a temperature, we can see more granularity there. We can actually look at the loop of the seasons, right? The cycle of seasons. Right? Now, what I think it was important was, since I had these individual stations, was to portray those stations, show each station, right? Not aggregate things in terms of averages, right? So I wanna find stations that actually are good representatives of the rising temperatures that we have nowadays. For that, this is barely visible, so let's, okay. So here I'm mapping all the temperatures, so these are temperatures graphs, verticals, okay, that are stacked on top of each other, and I'm visualizing the top 100 all on top of each other, so that I could already see if there was interesting data in there. After that, I did this application that basically presents me the stations that on average have risen more, right? So that I can select them, right? I can browse through them, look at the data quality, and depending on the quality that I have, I can select them and say, all right, I'm gonna portray this certain station. So the first attempt that we had was we started imagining the sea and the sea level rising, right? So for each data entry here, we have a minimum, a medium, and a maximum temperature. And as each temperature comes, right, it stays and fades out. So it's as if the sea was coming and going every time for each station for all the time. Since we were in the north here, I grabbed the Bragança station, so that's what I had in my data. It's very close, well, close enough. And you can see that as new maximums occur in the data, I'm leaving a mark in the sand, right? So as the visualization progresses, we have a maximum that is going to advance, 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 and advance. Right? We can actually visualize this for multiple locations at the same time. We have Vienna, New York State, Bragança, and Mexico. And we were trying to do something with the sound of ocean waves. So this is our first incursion into the metaphoric exploration here. But it was looking too relaxing. It doesn't look very urgent, right? So, in order to make it more urgent, we flipped the axis, right? So things were coming from above. Now they're coming from the bottom, right? Now it's a thermometer, right? Going up and down with the temperatures, right? And I also leave a mark, a trail of all the temperatures that we had, right? And now it's more nervous now, right? So now we are trying to go with this concept. So this is a kettle, right? And we actually want to use this data to generate that sound. So this sound is then on top of the visualization, but we want to use actually the temperature sound to generate this actual sound and make several pieces that show the rising temperature climate change. And this is our first incursion into this particular project. Thank you for having me.
Don't think it. Okay, it's working now. A quick question. I like the big format, the large format, and the print. How do you integrate that on your creative pipeline from the start, or do you transform your visualization into large print format?
From the start, I thought about print. So those are actual PDFs, very heavy PDFs. So with vector data that we use to make these printouts. And those are actually, if I recall, they are laser printed, so we would have the maximum resolution. So they were thought first as static pieces, and then actually we evolved after that to the animation, right? To showing how the algorithm works, how the simulation works.
Rodrigo?
Oi, Pedro. I have a question regarding what the process is of producing these visualizations when it comes to data granularity, because most of them rely heavily, because of the natural metaphor, on little tiny moving parts. And if you first look for a data set that's already granular enough so that you can create these kinds of things, or if you get something that's kind of aggregated and then try to break it into little tinier parts, for example.
No, that's a wonderful question. I already tried to go both ways, but I prefer to always try to get a lot of granularity as much as possible. So that's my approach. In my point of view, a lot of the gist about data visualization is to try to show patterns, to make those emerge visually, right? And then from there, we can get into analytics and we can try to explore certain patterns more analytically, right? I also tried indeed to work with aggregated data, but then I found myself of artificially having to break those, so I was already kind of trying to create data, doing fake data, which is actually something that the census is doing nowadays for, at least in the US, for the community survey census, so they are only making available synthetic data that is representative of the thing, but it's not the real data. So this work wouldn't have any value, the diversity traces wouldn't have as much value. Yeah.
There is one from online, from Gabriel Rezende. How you see people that has been identified with low data literacy can understand or feel your work?
Can you repeat how I...
Yeah.
Thank you.
How do you see people that has been identified with low data literacy can understand or feel your work?
Yes, so I think about that because I want my visualizations to be as accessible as possible, right? That's why I work with these natural metaphors, so that we have some familiarity with them already, right? So we already have some familiarity with what are trees or tree rings. We already have this imagetic of chromosomes, for example, right? We also thermometers going up and down, so I try to bring all of those elements from our metaphoric collective imaginary right into the visualizations themselves.
Sounds good. Well, we do have time for one more, if someone wants to. Okay, here in the front.
Hello, thank you. I really like all of your work, so I'm glad I got to see it today. My question is, when you're working with natural systems, how do you debug things? How do you know when your code is wrong or when that's actually just emergent natural phenomena?
How to debug things, and again, in what terms? If it's what or what?
Oh, it was just an example, like how do you know it's a coding error? Or how do you know it's like, oh, that was supposed to happen because of randomness or because
Gotcha.
of what have you?
Yeah. All right. No, that's, it's a tricky one because, this, at least for the tree rings, it was, I went through a lot of experiments going with things that don't look like tree rings at all, right? And sometimes coming with these malfunctioning algorithms that kind of explode and nothing works anymore. So it's mostly trial and error, and when you look at the patterns, right, I always try to validate them. So indeed, if I saw a series of thinner rings, I went back to the history and tried to see if there was a reason why that happened. I tried to go to other authors to verify the thing, right? And also going through the codes more carefully. But it's a lot of trial and error. Indeed, those natural simulations, they sometimes have those non-deterministic aspects, which sometimes may cause some accidents in there, which may be or problematic, or sometimes they add to the expressiveness of the visualization. So one has to be very careful to balance those two.
One last question there.
Hi, I'm Vivian. I wonder why did you choose doing the census data with the US data and not, for example, with Portugal data?
Mm-hmm.
We are not judging you.
No, the harsh reality is that I was on tenure track in the US, so I thought it would be more impactful there. But also, truth be told, I had a lot of access to micro data from the census. So I really wanted those couples, for example, right? The real couples, right? And at least when I looked for data, statistical data from Portugal, for example, I could only find aggregated data, right? I could only find, general ratios of racial distribution, for example. And I think here in Portugal, we don't even have to answer that in the census. So it was kind of working with the data that I had. But I think it's interesting to expand this to other countries, as I did for Rio, for example, right? Since the story of the immigration for Rio was negligible comparing with the one that you had to the United States, there was a bigger one that was more local, which was the internal migrations to Rio, right? And that was what made a story that people there could connect with, because they knew when lots of people came from the south, other people came from the northeast, and so on, right? So whenever there is the opportunity and the data is rich enough, I try to use those data.
Well, thank you very much. Thank you, Pedro. And
Thank you.